This is part 3 of our discussion about electromagnetic interference. In this episode, we'll discuss design challenges and solutions related to EMI in the telecom industry.
So the telecommunications industry is also in the midst of really massive change. James, I'd like to ask you, what unique EMI challenges do design engineers face in telecom?
Yeah, you're very right, Ethan, that telecom and the designs for that have radically changed, going from 4G up into the 5G range, where the frequencies, because of that, have gone from sub-6, typically 4G is around 1 gigahertz, 700 megahertz in that range. Now they've gone up to 28 gigahertz, 39 gigahertz, and that takes, from an EMI perspective, is a completely different playing field. So different techniques are needed. As it was kind of mentioned, board level shields or the traditional kind of EMI mitigation techniques really are not as effective at the higher frequencies. And so absorbers or other techniques really come into play when we get up into those frequency range. Because of that smaller wavelength, the board level shields and other things just are not as effective. And we also see with the different designs for 5G, we get into the MIMO antennas, where you've got antenna arrays. They're very small and they're very packed together, an array of different devices that are there. And they have to be cooled, but they also need to have EMI mitigation associated with it. So that's where Laird has the innovative products where it's combined together, the CoolZorb product line, where absorber and thermal interface materials are combined together in the same material. So you can please the thermal engineers and you can please the EMI engineers, because you can handle both aspects of things within the design. And as things are getting smaller and smaller in those elements, that really is a key element to the design. And then other things that traditionally, like the radomes, were something that people would say, I didn't know Laird did that. And we hear that quite often because we have such a variety of different products. And so we even have low decay materials. And now, especially as we're part of DuPont, that's really exciting that we can expand, on, particularly in that field, of coming up with new innovative radomes that really become much more critical at these higher 5G frequencies.
James, you mentioned the combination of thermal and absorber products in one. Can you give an example of a really hard challenge where you had to solve an EMI challenge and also thermal, and you were able to use one of these combination products?
In the telecom world, I think the perfect example is that of the antenna arrays that are there, where you have an array of up to 64 chips that are tightly packed, and they are generating a lot of heat, so they need a very large heat sink to be very close to them. But then you get this large metal plate, which you get capacitive coupling, you get a lot of other issues, you get back reflection associated with there because those elements are broadcasting out. And so by having that combination materials, you're providing the thermal solution, the thermal pathway to that needed heat plate, but then you're also providing the absorbative element of the CoolZorb, so that you don't get the reflective bounce back off of the heat sink. You don't get the coupling. You reduce all of that. So it's a unique product that can really solve the issues that the design engineers are facing.
I'm just curious. So you mentioned 5G as a big driver for innovation. Where are you seeing the most interest now from your customers? Is it the level of the microcell, the macro cell, at the handset level? Where's the most action right now?
Actually, it's across the entire spectrum of things, because you have the antennas that are out broadcasting, you have the base stations, which are still needed for everything. But then, especially with 5G, the frequencies can only penetrate so far, and the distances. So now you get into the smaller repeater cells or other things that are needed within structures. So it's a whole infrastructure that is all based around the 5G, the higher frequencies.
That's really exciting activities that are going on right now. it's almost hard to envision what could happen 5 years from now, but I still want to ask that question. Where do you see EMI mitigation heading in the next 5 years? What new problems are we going to have to address, and where's the technology team going to have to come up with new inventions to solve our customer problems?
I think you're just going to see really a continuing trend of what we're seeing now. Thinner, faster, smaller, more flexible. Operating speeds are just going to go skyrocket. And I mean, they will continue to skyrocket. We're not looking at 1 to 2 gigahertz to 3 gigahertz. We're looking at, if you listen to James, 3.5, 29, 38, and up. And it will just accelerate. So that just means Laird has to meet those demands with other materials. He also mentioned combining materials together that perform both thermal and absorption. Well, Laird is now combining more and more materials. It's not just combining to make the cool absorb. Also, we are having to incorporate and design a product that not only does, say, a board level shield that does shielding. It's also is designed to make the board more rigid, so it becomes more of a structural metal, along with a thermal pad on the outside and on the inside to help help mitigate the thermal issues, and then maybe even add absorber or an absorber coating on the inside to help absorb the EMI interference that, of course, your shield or board level shield is not able to shield. It's going to be challenging. It is going to be challenging, but Laird is stepping up to the plate. And as James also mentioned, very excited to see how we can take the products that DuPont currently manufactures, merge them together, the products that Laird has been manufacturing for years and years, and see what new products we can bring to you.
Oh, that's great. And I can tell you that we're already seeing that the material science capabilities coming from DuPont are going to greatly accelerate our ability to create new products through Laird Performance Materials. So keep the problems coming because our toolbox is getting bigger and bigger day by day. Thank you all. And thanks for tuning in to this episode of Insights Engineered. Visit Laird.com and follow Laird Performance Materials on LinkedIn to learn more about our latest products and innovation.